Ever wondered how the intricate mechanisms of a mechanical watch, the aerodynamic curves of a sports car, or the complex systems of an industrial machine come to life? The secret lies in a process called mechanical computer-aided design, or CAD. The journey begins with conceptualization. Picture a designer pondering over functional requirements, design constraints, and user needs. Rough sketches and ideas start to form, shaping the initial concept of the mechanical product. As the concept solidifies, it's time for parametric modeling. This technique allows the creation of a three-dimensional digital model where parameters and dimensions can be defined and relationships set. This is the stage where design changes and updates become a breeze. The focus then shifts to part design. Here, individual components of the mechanical product are detailed, with each part given specific dimensions, tolerances, and material properties. Next, these individual parts are assembled into a complete three-dimensional assembly. Relationships and constraints between parts are defined, ensuring an accurate fit and function. The process then delves into the dynamics of the assembly with kinematics and motion analysis. This stage simulates the movement of the mechanical assembly, evaluating the interactions between components and identifying potential issues. To ensure the structural integrity and mechanical performance of components, a finite element analysis, or FEA, is conducted. Factors such as stress, strain, and deformation under various loading conditions are evaluated. For the creation of complex shapes and organic forms, surface modeling techniques are employed. This is especially useful for designing aerodynamic components and intricate geometries. A fascinating part of the process is generative design. Here, algorithms and artificial intelligence automatically generate optimized design solutions based on specified constraints and goals. As the design approaches completion, it's time for drafting and detailing. Two-dimensional drawings are generated with detailed views, dimensions, and annotations that manufacturers can use to produce the parts. Collaboration and version control are essential throughout the process. Stakeholders such as engineers, analysts, and manufacturers work together, managing changes and revisions to the CAD models. Integration with simulation software allows for further analysis and optimization, while connection to computer-aided manufacturing, or CAM software, generates toolpaths for CNC machining. Finally, CAD files are exported in various formats for sharing, and effective data management practices are implemented to organize and store CAD files securely. So the next time you marvel at a mechanical masterpiece, remember the meticulous process of CAD design that brought it to life. From conceptualization to data management, each step is a testament to the power of technology and the ingenuity of the human mind.